Okay. So the first one, they gave you the point A and the point B, and I told you that the distance between them, the length of the line, is the root of 52. Eh? So they want you to find the value of k. That means if you take the distance formula, I just want to show you this one. We didn't get a chance to talk about it. If you take the square root that was there over to the left hand side, then your formula will look like this. It's just d squared. Then it looks exactly like Pythagoras. Hypotenuse squared equal to right angled side squared plus right angled side squared. So it's not a different formula. It's the same formula, but just one step ahead. So I would suggest if they give you the distance and you want to calculate one of these, I would use it where the root has been taken over. Do you understand that? I wrote it there on the board as well. They look the same, those two at the bottom, or they mean the same, but they look a bit different. Okay. So I substitute into it the square root of 52 equal to substitute. Then I square the bracket. It's the first one times itself, the first times the second times 2, and then the second one times itself. If you swap the k and the 4, your order would just be different. And then here it gives me a positive 6 squared, which is 36. Then you get everything on the same side. You get k squared minus 8k. Do you agree with that? Okay, do you remember how to factorize this? You just take out something in common. Then you've got k bracket k minus 8, and your two answers will be 0 or 8. Did you get it right? Well done. Okay, B was a bit more difficult. So what they're saying here is they are telling you that the distance between A and C is the same as A and D. Okay. But in actual fact, if you think about this, you've got two unknowns, two variables in this sum. You don't know what the y value of A is, and you also don't know what the distance between them are. So you've got two unknowns. When you've got two unknowns, remember I told you you need two equations. So you can get two equations by taking the distance of AC and taking the distance of AD and letting them be equal to each other. Does the plan make sense? Okay? If I say 5 plus 7, let me write it here. If I were to tell you that 5 plus 7 will be the same value as 3 plus something, do you agree you've got two unknowns now? You don't know what, I haven't told you what 5 plus 7 is, and I haven't told you what plus 3 will give you the same answer. But what I'm saying is if you take 5 plus 7 and you let it be equal to 3 plus x, then I can solve for x. Because the one variable, the unknown, equal to, let's call it y, that value is y. This one is also equal to y. And when they're equal to the same thing, I can let them be equal to each other. Do you understand? Who says no? I hear a no. Or am I not hearing correctly? Okay, let me show you the sum, then maybe you will understand better if you are still feeling unsure. So I said I'm going to take the distance of AC. Substitute into it. X minus x squared, y minus y squared. And I let it be equal to the distance of AD. So this is AC, this is AD, because they told me they are equal. Then I just substitute x, those two x's, those two y's, square and add. And now you must just do the sum. So -3 minus 7, -10 squared is 100. P will become, it will be P plus 1. It's P squared, first times, second times 2, and then the second times itself. That gives me 7 squared is 49. P plus 4 times itself, times that one, times 2, times itself. And then you will see I crossed out the P squared on both sides, because it's plus P squared and it's plus P squared. You see that? And then they're gone. So you just get all the P's on one side, get all the numbers on the other side, and then you've got one answer. P is equal to 6. Okay, I want you to quickly do number 4. Oh no, we're busy with number 2, sorry. Number 2a, they gave you the midpoint. They wanted you to calculate one of the coordinates. This was easy, ne? So we just say x plus 6 divided by 2 is -2. They gave me the answer. And then negative, or y plus -3, but it's still plus, ne? But the plus and a minus is a minus. That's why it's minus there. Y minus 3 divided by 2 equal to 4, and then you solve it, you get x to be -10 and y to be 11. And then B, same type of sum. 4 plus x divided by 2 is -2, and then 3 plus 7 divided by 2 is y, and then you get x -8 and y 5. Can I page? How are you not getting this right? Huh? Yo. Problems, big problems. Okay. I want you to do number 4 with me. Just quickly open your textbooks. Or wait, you can listen to me. You can listen, it's fine. I will tell you what the question says. So they said that you've got 4 points. That is a parallelogram. And you have to determine whether the diagonals are bisecting each other. Okay, so the first problem that we have is that we are going to have to draw the sketch. Because if you've got a parallelogram ABCD, then we don't know, will the diagonals be AB, AC, or AD? Do you understand what I mean? We don't know where the points are situated. Opposite which one, where. So you're going to have to draw it. You don't draw it on scale. You draw it as you like. Just guess roundabout where you think the coordinate will be. So that's what I started to do. I drew the parallelogram. Quickly do it. Do you know what a diagonal is? The line from the one angle to the other angle. Who says ma'am? Now, after you've drawn the diagram, we can all see that the diagonals will be AC and BD. Do you agree with that? Okay. While you're drawing it, I want you to think of a plan. We've got a distance formula, we've got a midpoint formula, we've got a gradient formula. Help me think of a plan that we can use to determine whether the diagonals bisect each other. Do you have a plan for me? No plan. You don't have to page to find something. Yes, Moto? What is the gradient? What do you want to do with the gradient formula? Okay, but remember, two things can be perpendicular to each other. Those two things are perpendicular without bisecting. Remember, bisect means you cut in half. Okay, so it's a good plan. At least she's got the plan, but you understand why it won't work. If the question was prove that they are perpendicular, then we'd use that one. Anyone else? No one. No one even thinking about trying to calculate the distance and the distance and the distance and the distance, but now you see the problem, we don't have the coordinate in the middle. You see that? Okay. Let me help you with this one, and it's a very important thing, and that's why I'm showing you or doing this sum with you. If I've got two rulers, and I want them to bisect each other. This one is 22 centimeters, this one is 30 centimeters. Where must I let these two cut each other for them to bisect? This one is 22, this one is 30. 11 and 15. There. Do you agree with me that their midpoints, their centers, must be on each other? So the midpoints must be at the same place. If I take the long ruler, it's still being cut in half, it's at 15, but if I put it at 19, do you see then the blue one is still being bisected, but the white one is not being bisected. But if both of their midpoints are on the same place, then they bisect each other. Having said that, when we want to prove that two lines bisect each other, we are going to prove that their midpoints are the same. So we're going to calculate the midpoint of BD, get the coordinate. And we're going to calculate the midpoint of AC, get the coordinate. And if those two coordinates are the same, then these two lines are bisecting each other. Does the plan make sense? Very important plan. That is one of the proofs to prove that this is a parallelogram. We prove that the diagonals bisect each other. Right, so I take the midpoint of AC. I substitute into the formula, easy calculation, eh? Easy calculation. And then I get an answer of 1/2 and 1.5. Okay. Now we're going to calculate the midpoint of BD. And I find it to also be 1/2 and 1.5. And now we are going to say, you see midpoint we show with a capital letter M, né? And gradient will be a small letter m. So I say the midpoint of AC is equal to the midpoint of BC, no BD, sorry. Okay, I want to just quickly focus your attention on the sum that we just did. Do you agree with me that the maths that we did wasn't hard? It wasn't like number 1B, né? Like that part. The maths, the things that I can teach you is not hard. It's a formula that we learn, we substitute into the formula, you calculate it. The thing that is hard, and that is what catches up to us, is the problem solving skills that we need. Okay? So I can give you extra classes every afternoon from 2 o'clock until 6 o'clock. This is the only thing that I can teach you. The problem solving I cannot teach you. Do you understand what I mean? It is a skill. And you only get it by practicing it yourself. So you will see we are going to finish the whole trigonometry, analytical geometry today. We're finishing it. Then we're going to work out old question papers. Because that is the best way that I can help you get the skills. But more than that, I can't do. Okay. So the sum isn't difficult. If you were to get this sum now, and I would whisper in your ear and I'd say, prove the midpoints equal to each other, you would get full marks. If I tell you, show that the lengths of the sides are equal, you would do that, because the maths is easy. But figuring out that you need to prove that the midpoints are equal, or figuring out that the lines are equal, or figuring out what you must do where, that's the frickin' difficult part. And that only you can help yourself by practicing and practicing and practicing. I'm going to give you old question papers, but you're going to have to do more than that, especially if you're struggling. And it's like the Euclidean geometry. If you don't see, and you come to me or to whoever every time and you ask them to show it to you, then it's actually not helping. You must struggle until you start seeing it. Because I'm going to sit here, I'm going to show you. I just said, prove the midpoints equal. Oh, that's very easy. Thank you, ma'am. There we go. Okay. So you need to put in the effort by yourself as well. Otherwise, you are not going to get, or to be able to do this. All right. That's that up to there. I want you in your workbook to write a heading. This is grade 11 work. Everything we've done up to now was grade 10 work. This is an inclination angle. Okay, the inclination angle is the angle created between a straight line and a horizontal line or the x-axis when measured anti-clockwise. So there's a straight line, there's the x-axis, it's the size of that angle. Do you see that this straight line AB has a positive gradient? No. Positive gradient. You know what a positive gradient looks like? When you read from left to right, it's increasing. Then it's positive. If you read from left to right and it decreases, then it's a negative gradient. The positive gradient, do you see there, has an acute angle. The negative gradient has an obtuse angle. Now, do you know what it means when we talk about the incline of something? The incline. What does that mean, Kumo? Okay, it's how high it goes up, ne? If you're running on a treadmill or something, it says incline. You press 1, then it lifts a bit, then 2, it lifts a bit more, and 3, it lifts a bit more, 5, 6, 7, it lifts more, and it becomes steeper. So it feels like you're running up a hill. Okay, that's what incline is. That's exactly what this is, the incline, the inclination angle. Now, do you agree, the bigger the inclination is, the steeper it would be. If the angle was very small, let's pretend you have to run up this hill. If this angle was very small, it would be flat. Eh? But the bigger the inclination becomes, the steeper it becomes until it's 90 degrees and then it goes to the negative. Okay. Now if this is theta and I consider tan theta, can you remember what tan is? What? Except for that. Opposite over hypotenuse. Do you remember? Okay? So it's this side, opposite over hypotenuse. Adjacent. Opposite over adjacent. Now, which axis is this opposite? Y. It's Y. And this one? X. Now, do you know how to calculate the gradient? It's the difference in Y divided by the difference in X. Now, do you see that tan theta and the gradient is equal to the same thing? The difference I'm referring to here, if that was a value of 3, let's say it's the point 3 and 4. The gradient would be 4 minus 0. Do you agree? Divided by 3 minus 0, which would be 4 over 3. The tan would be opposite over adjacent, which is 4 over 3. And that's how we get to the formula for the inclination angle, that tan theta is equal to m. The tan of the inclination angle is equal to the gradient of the line. This makes sense, right? Ne? I proved it to you there. don't you just quickly borrow that summary that I gave? Right, you all understand? Alright, now let's see how we will use this. You'll see after the gradient it starts with collinear points. We'll go back to it in a minute. But I want you to go to point 3 of grade 11, the inclination angle. Okay, the inclination of a line is the angle that the line makes with the positive direction of the x-axis. Now the reason I wrote it a bit different there for you, I said that it's the angle that it makes with a horizontal line. And then I said in brackets the x-axis. Because if your line ended there, let's say I want that line, inclination. You don't have to take this down to the x-axis. The angle it makes there will be exactly the same as it makes there, because it's like a corresponding angle. So it doesn't necessarily have to be the x-axis. It must just be the angle that the line makes with a horizontal measured anti-clockwise. Okay. So if tan theta equal to m and m is greater than 0, that means the gradient is positive. Then the angle is acute, smaller than 90 degrees. If the gradient is smaller than 0, in other words negative, then theta is between 90 and 180 degrees. It's an obtuse angle. Now let's look at this. Find the angle of the inclination of the line passing through the points -2 and 2 and 4 and 3. Now what we're going to do is we're going to use these two coordinates to calculate the gradient. And we get the gradient 5/6. So I want you to quickly take out your calculators. Let's just see if we can get it right. Now if we have tan theta equal to 5/6, we want to get the theta alone. No? We want to calculate the inclination. Then we're going to have to press shift tan, and then on the fraction 5/6 and equal to, you get an answer of 39,80. Does that make sense? That means that angle, the angle that the line makes with the x-axis, is 39 degrees. Okay, if the gradient is 5/6. Now the next one we're going to look at, and here you have to pay very, very, very good attention. Pay all your attention. You must wake up now. If you've got -3 and 3 and 2 and -4, you're also going to calculate the gradient. Eh? But then you get an answer of -5/7. Now if you use your calculator and you type in shift tan of -7/5, you get an answer of -54. Now the reason for that is because, do you remember the tan of a negative is the negative tan of the angle. So your calculator is always going to throw it as a negative. So this you must just remember, if your gradient is negative, you press shift tan 7/5. You ignore the negative. Okay? Then when you get your answer, you'll get 45,46. But remember, we know this answer is negative. So it's not in that first quadrant, it's not 54,46. It's in the second quadrant. How do we get into the second quadrant? 180 minus. And that's why we say 180 minus the answer that we get, and then we get our obtuse angle. Does it make sense? Okay. That's the only trick with inclination angle. Either the gradient is positive, then you just say shift tan, you get the answer. Or If the tan is negative, you ignore the negative and you take your answer and subtract it from 180. You're going to see when we work out the question papers, the way that they make it a bit more difficult is they'll give you, there will be a triangle created by the lines, and you will perhaps have the exterior angle with the inclination angle. You have to calculate another angle. So we bring in some of the Euclidean geometry as well. But you will see when we get to that. Okay, now you can just look at the previous page. No, not the previous one. Where grade 11 analytical geometry starts. Only two things that we learn in grade 11. It's the inclination angle, and then it's the collinear points. Now, collinear points means if you have a straight line and there are coordinates on this line, if they're collinear, they're all on the straight line. You can imagine if this gradient and this gradient is the same, they must be on the same straight line. But if the gradient between B and C is different, if it takes a knock, then C can't be on the same straight line. Does that make sense? Okay. So if we want to prove collinear points, all we're going to do is we prove that the gradient between A and B is the same as the gradient between B and C. Or we prove that the gradient between A and B is the same as the gradient between A and C. That's all. It does happen that maybe they'll give you 4 points. Let's say there was a D as well. Then you can't just calculate the gradient between A and B and then the gradient between C and D. Because they might be parallel, then they're not on the same straight line. So what we're saying here, prove two gradients equal and state and give a common point. So what that just means is, if you're going to calculate the gradient between A and B, you also have to calculate the gradient between B and whatever. B is the common point. Okay, so you only have to prove two gradients, but one of the variables must repeat in both of the two sums. Or A and B and A and C. So A repeats. Very easy. We're not even going to look at the first one. We're always going to use the second one. So I calculate the gradient of A and B, I get a half. I calculate the gradient of B and C, I get a half. And B is a common point. So they must be collinear. Just gradient calculations. Do you understand? Everyone? Okay, that's it for collinear. Let's just quickly look here. No, grade 8, why are you laughing? Are we going too fast? Oh no. That's it for collinear. We're still doing a lot today. If I give you 4 points, A, B, C, and D, with their coordinates, D is missing something. And they tell you that A, B, and C, D is parallel. What extra piece of information does that give us if I tell you that AB is parallel to CD? What? What does it mean if they are parallel? These two things can be parallel. These two things are parallel. Dankie, Tabisu. Tell them their gradients are the same. Did you say that, Moana? Then you must take off the mask so I can hear. Shout at me, I'm deaf. Okay. It would mean if I calculate the gradient of AB, I have the gradient of CD and then I can find the unknown variable. Make sense? Yes. 2.2, if I tell you that AB is perpendicular to CD, the product of the gradients will be -1. So you can calculate the gradient of AB, swap it around, give it a negative, then you've got the answer of the gradient for CD. Nee? Do you know that? Last one, BC and D are collinear. Then I can calculate the gradient of AC, for example. Then I've got the gradient or the answer for CD. But not AB and then use it for CD. Nee? Without the A. Just BC's gradient and then I've got the answer for CD. Because they're telling me B, C and D are collinear. Okay. That's it for parallel and stuff for today. Open your books. Okay, quads. Let's see how far we can get before the bell goes. We've still got 10 minutes. Right, you have to hurry, hurry, hurry. Be quiet. Why are you guys so noisy today? What? Who is moaning? Ungoni, tell me. No. You know what? It's so easy. Go get the subject change formula. You see Boka is running around doing nothing. He wants to come and care here. Then you can go and care wherever you want. But you're going to stop wasting my time now, and I have to keep asking you to be quiet. Khali. Okay. You know we get different types of doctors. Ne? What is the normal doctor? I am referring to all medical doctors here. If you go to the doctor and you have a flu, which doctor do you go to? You're not a child. You go to a general practitioner, a GP. Have you heard about that? A GP. Now our quadrilaterals are like doctors. We have our GP. Our GP is the parallelogram. Right. The parallelogram has got opposite sides that are equal to each other. Two pairs of opposite sides equal. So they're not all equal to each other. Two pairs are equal. It's also got opposite sides that are parallel to each other. Two pairs, opposite sides, parallel. Okay, when we look at quadrilaterals, we look at their sides, then we look at their angles. It's got two pairs of opposite angles equal to each other. These things you've known, eh? And then the third thing that we look at, and this one we look at a lot in grade 11. So I'm going to have us write it down as well. Maybe you remember it from previous years, but this one we haven't used as much in previous years. And that is about the diagonals of the quadrilateral. Now, this one we did when we did that question 4 that you did with me. Right? Do you remember what we did there at question 4? Yes. We proved that the diagonals bisect each other. So, this is the third thing we look at. It's the diagonals, and we refer to the diagonals a lot in grade 11. And they bisect each other. Does that mean that they are equal to each other? No. It means that this line cuts this line in half and the other way around. It doesn't mean that this line and this line is equal. One thing we also have, but that's obvious, is that the vertically opposite angles will be equal to each other here by the diagonals. So I just want you to remember it's got all of these properties, but I want you to write down this one. It's the diagonals bisect each other. Okay, the next doctor we're going to look at is a cardiologist, for example. Now, do you know what a cardiologist is? He works on your heart, ne? Yes. Okay. So, the cardiologist, is he also a normal doctor, a GP? No. Yes. He had to become a GP, a normal doctor, and then he specialized to become a cardiologist. Do you understand? So if you have connections and you have a flu and you want to go to a cardiologist for a flu, then you can do that as well. He has the expertise to help you with your flu. But is the GP also a cardiologist? No. So the cardiologist is a GP, but the GP is not a cardiologist. You get that? That's the same with the quads. The parallelogram is the GP. The cardiologist, let's look at it. Let's make it the rhombus. A rhombus, listen to what I'm saying. A rhombus is a parallelogram, but a parallelogram is not a rhombus. Because a rhombus has the same properties as this one. It has opposite sides equal and parallel. It has the opposite angles, two pairs being equal. And it has the diagonals that bisect each other. But it also has something extra. Let me finish this one. The thing that it has extra is that all four sides are equal, not just two pairs that are equal to each other. All four. Not opposite, also adjacent. They are equal to each other. Okay? That one you know, ne? You knew that the rhombus' sides are all equal. But the one that we haven't worked with as much, with a rhombus, the difference between a rhombus and a parallelogram, is that the diagonals, they don't just bisect each other, they are also perpendicular. Now, while you're finishing writing this, I want to tell you something quickly. Tomorrow we're going to look at the rectangle and at the square. If, for example, in an exam, I ask you to prove to me that this is a rectangle, and you prove that the diagonals bisect, which is true for the rectangle, the diagonals of a rectangle do bisect, you would get it wrong Because the diagonals of a rectangle bisect. The diagonals of a rhombus bisect. The diagonals of a square bisect. And the diagonals of a parallelogram bisect. So have you proven that it's a rectangle? No, you've proven it's a parallelogram because a rectangle is also a parallelogram. It doesn't say it's a rectangle. So all of the specialized doctors, they are GPs. But the GPs aren't all specialized doctors. And that's what you must understand, okay? So tomorrow we'll look at the rectangle and then the square, and then we're starting with exam questions.